Okay, you sent us a number of questions, and one of the questions you sent us was what is the difference between the use of high lift devices during takeoff and during landing. Well, I made this sketch here on the board, as you can see, presenting the situation during takeoff and situation during landing. And if you look at these, the biggest difference is what you see here is, for instance, that in most cases during takeoff we do not use the slats, and the flaps are extended, although not to full extent. Usually 15-20 degrees flap position is in many cases sufficient for takeoff. For the landing, however, when we come down, we would like to optimize, to maximize the wing area and also to maximize the curvature. And what we do then is that, of course, also use the flats, the slats on the leading edge, and also using the flaps at the trailing edge. And now we fully exploit, in many cases, these flaps. Also realize that during takeoff we increase in speed. So that means that when we go faster and faster, we are going to reset the situation as in flying conditions. Whereas during landing we are going to decrease the speed. So therefore we will see more and more the curvature and more the increase of surfaces. So in most cases, summarizing, most cases during takeoff we only apply flaps, and during landing we use both systems as well as slats and flaps. Another question we got from you was how to calculate the hoop stresses for a cylinder, for a fuselage with a square cross-section. Well, we derived in the course itself, we derived it for a circular one. So I will start again with a circular cross-section. And that's what you can see here. Part of a cylinder, part of a tube, and we do have hoop stresses and we do have longitudinal stresses. If I look at the cross-section itself and make a scission, if I cut them into half, I get this situation. Yeah, so I have here half the circle, and what I'm looking for, if I look for the hoop stresses, I'm looking for these types of forces. These two stresses, these two forces. Those are the hoop stresses, the hoop forces. I can find that just by integrating over the surface all the pressure differences. And I need there the vertical components, of course, to have these two stresses. In similarity, we do like here, also for a square cross-section. Same picture, vertical stresses, horizontal stresses, cut them into half, and then we get this picture. And again, we just need to have the integration now again over this surface, but it's much easier here to do that than in that case. But in both cases you can quite easily obtain your hoop stresses. One further comment, realize that if you have a pressure cabin, in most cases we do have circular cross-sections. You never see pressure cabins with square cross-sections. And you may ask why, but that's one of the exercises also to think about it. Why is this not as efficient as that one?